Hey everyone, welcome to day 4 at GITEX 2019. My name's Aries Bungie, and I'll be your chair, MC, whatever you want to call it, as long as it's one of those two, for the X Labs track today. I'm a 14-year-old blockchain machine learning developer and newly minted philosophy and wireless energy enthusiast, so I think that just about qualifies me. I'll be introducing the speakers, cracking a few jokes, and hoping you have a blast. So if you stick around, you're going to see a lot of me. I'm really excited to learn from all the speakers today and explore different technologies. So with that, I'll introduce our first talk for the day. To paraphrase David Letterman, our next speaker needs no introduction, but that's because he's already had one. He's a 14-year-old blockchain machine learning developer, wireless energy and philosophy enthusiast. It's the one, the only, me. Usually I thank the person that introduced me. In this case, it's myself, so I feel like that would be a bit narcissistic. I'll go ahead and do the next best thing, which is talk about myself. This summer, I actually interned at Microsoft, which is the world's biggest company, and this was an amazing experience for me. I learned so much at only 14 years old. But you're probably asking yourself, how did a 14-year-old get an internship at the biggest company on the world? Well, about a year ago, I joined this program called the Knowledge Society, and that's when I really started learning about new cool emerging technologies like artificial intelligence, and more importantly to you, blockchain. I recently spoke at the Scotiabank Digital Factory, and for the Dubaians in this crowd, Scotiabank is one of the biggest banks in Toronto. So this was an awesome opportunity for me to share my knowledge with everyone at Scotiabank, and now I'm doing the same thing here at GITEX. So that's probably enough about me. Let's talk global problems. Who here has heard about the 2010 earthquake in Haiti? That was a terrible natural disaster, and countries had to pour $13 billion into Haiti just to keep it running. What about the disaster that was the 2016 US presidential election? There were a ton of doubts about the security and the accuracy of that election, and that was just a huge disaster. And back home in Canada, we have a ton of issues with romaine lettuce, how it's being handled, and whether or not there are some really bad bacteria in them, like E. coli. So I'm here today to talk to you about blockchain, but I'm not here to talk to you about how blockchain can solve all these problems. Because the fact is, blockchain can't stop the movement of tectonic plates. It can't stop people from improperly washing romaine lettuce, and it certainly can't change the writing on ballots. So I'm not here to talk to you about how blockchain can solve all this. What I am here to talk to you about is my vision of a future with blockchain. If anyone's seen the movie Avengers Age of Ultron, you'll recognize this scene. If not, watch it, it's a great movie. But in this scene, one of the main characters is talking about his vision for the future. I see a suit of armor around the world, and this is an iconic line that really got me thinking about what I see for the world. And no, it's not a suit of armor. But when it comes to blockchain, what I see is global networks, connecting people and things, constantly verifying data, making sure it's accurate, making sure it's secure, digital, indestructible, keeping records like healthcare, food, property ownership. I see blockchain taking on a major role in the future, and that's something that I want to be a part of. But for our blockchain novices in the crowd who don't watch their daily 10-hour documentaries, you're probably wondering, what is blockchain? What's this global network that this guy's talking about? Well, I've been told that it's best to explain blockchain with an example or an analogy, so I'm going to go ahead and use both. Imagine, if you can, that my sister is sending me 12 Ether, so basically online money. It's hard, but you can do it. And now imagine that each and every one of you here today have a ledger, like the kind you'd find at a bank. And your ledgers are all reporting every single transaction, including the one that my sister is making to me right now. So, your ledgers are all completely synced up, which means you all see this transaction at the same time. But what happens if my sister tries to erase that transaction, make it like it never happened? Well, that just doesn't work. You see, the ledgers all operate on the law of majority rules, which means if over 50% of them say the same thing, then they all do. It's also important to note that there is no government with complete control over all of your ledgers. This is called decentralization, and that's a fancy word for no super user, no giant bank that can edit everything. You have the ledgers, not them, so you have the power. It's that simple. So back to blockchain. Instead of transactions on your ledger, let's go a little deeper. Now you've got blocks, and these are basically just bundles of transactions, but you also have something called a hash. And this hash may not seem important, but it actually is when adding new blocks. Let's use the example of the SHA-256 hashing algorithm. So that means that all of these hashes are really just 256-bit strings of numbers and letters. But when you're adding a new block, this becomes really important. People called miners have to try and guess the hash of this new block, and because it's 256 bits, this can take billions of guesses, and it drives their electricity bills up sky high. But once a block is added, all the transactions within it are verified, and I get my 12 ether from my sister. Let's go a little deeper into hashing. This is what the hashing algorithm looks like. Super complex, so let's break it down. This is the innermost kernel, hash of the transaction details. And what's happening here is some of the transaction details are going into this unknown hashing algorithm, and it's spitting out this 256-bit hash. Simple enough, right? Now let's add something else, the nonce. And what this is it's really just a completely random string of numbers and letters. And when I say completely random, I mean as close to random as we can get. The line over there just denotes concatenation. So you add the nonce to the end of the hash that you already have. And finally, you just hash everything one last time to get it back down to 256 bits. And that's hashing. So how does a hash make the blockchain secure? Like, it's just a bunch of numbers and letters, right? But every block also contains the hash of the previous block. So if someone tries to edit the hash of one of the blocks, they also have to edit the hash of the previous block, the block before that, etc., etc. And if I kept saying etc., I'd be here until next year, so I'm going to stop now. Interesting fact about how the blockchain gets its name. You can see in this diagram that every block is linked to the block before it, forming a chain of blocks, or a cheesy joke. That's how we get blockchain. See, I told you it was cheesy. So now we know about hashing, we know about blocks. Let's look into something more interesting. How about dApps? And you're probably wondering right now, what is a dApp? Let me explain. But first, we're starting with a blockchain called Ethereum. And Ethereum is actually a really special blockchain. It's not like your cookie cutter Bitcoin. It has this cool thing called the Ethereum Virtual Machine, or EVM. And what this allows you to do is code directly on the blockchain. So you can code anything from 2+2 to Pong to actual apps. And whenever an app is coded on the Ethereum blockchain, it carries some of that blockchain's characteristics, including its decentralization. So we call these decentralized applications, or dApps, because that's faster. This is what the structure of a dApp looks like. And you can see at the top there, you've got the front end. So that'd be your HTML, CSS, just to make it look pretty. Then you have smart contracts. And a smart contract is really just a self-executing piece of code that functions kind of like the back end of a regular app and makes everything work. And last, you have the blockchain protocol. And this is what enables the app to actually run on the blockchain. Do you remember earlier in my presentation, if you were here, when I talked about huge problems like Haiti and Donald Trump? And I told you that blockchain couldn't solve these. And that's true, like a dApp can't stop the movement of tectonic plates, but it can do something else. Let's take the example of Haiti again. And let me give you a little more background. After the earthquake that killed 230,000 Haitians, there was an even bigger disaster, the rebuilding of Haiti. And that cost $13 billion because of the fact that Haiti had thousands of plots of land whose owners couldn't be identified because the land registry had been lost or destroyed in the earthquake. And what this meant was that Haiti was in for a ton of delays and this huge debt just because they couldn't find a land registry. Whereas if they put it on the blockchain, it would have been completely secure. They could add permissions if they wanted to, and it'd be digital most importantly, so it couldn't be destroyed in an earthquake. In fact, there was recently a proof of concept done in a city known as Haryana in India. And what happens here when you want to buy a house is you haggle with the owner to get a fair price, then you both go down to a government office. You give the owner the money, the owner gives you the land deed, and it's input into the blockchain. That's it. There's no 60-day waiting period or anything like that. It's done in an instant, it's fast, it's efficient, and it works. It's that simple. But that's just one use case. Let's talk elections. I'm sure everyone remembers the 2016 US presidential election. I still don't know how Donald Trump won, but apparently he did. And if someone had just decided to put voting on the blockchain that year, it would have been completely secure and there could be no doubts or FBI investigation about how he won. It'd be simple. As for the other issue I talked about, with romaine lettuce, well, all you have to do is build something that simplifies the supply chain, a tracking system, and you can see exactly where things are going wrong in the supply chain, which is right now a convoluted mess. If you forget everything that I've just talked about, which is like the last 19 or so slides, and remember just one thing, I'm okay with that. But that one thing has to be a vision of the future, where everyone and everything are seamlessly connected through global networks, tracking property as it changes hands, food as it goes through the supply chain, votes as they come in. If you forget everything else, I want you to remember just that one thing, because blockchain is going to impact every single person in the future. That'd probably be good to remember too. Thank you.